What if your $2 million AI investment is running at 20% capacity and nobody noticed? Here's why that matters. I've been reviewing multi-agent architectures, and I keep seeing the same problem over and over. Beautiful individual agents, powerful capabilities, but there's a fundamental flaw that almost nobody talks about. So I'm Dougortiz, and I've been working in AI and data. I've seen architectures evolve from simple chatbots to complex agent networks. And what's at stake here is simple. Your AI infrastructure is either a collection of isolated tools or it's a collaborative digital workforce. Most companies have the first. They think they have the second. Here's what happens if you get this wrong. You invest millions in agents that can't work together. Multi-step workflows. All of these will require manual intervention. Your agents will sit idle 80% of the time. And your competitors who figure this out, they will run circles around you. The hub and spoke problem. Most AI architectures today use what's called a hub and spoke model. Think of it like an old-fashioned phone system. Every agent, your database agent, your LLM agent, your data lake agent, they all connect to a central orchestrator. But here's one thing. They only connect to the orchestrator. They can't talk to each other. The orchestrator routes messages using keyword matching, simple substring matching. You say database query, and it sends to the database agent. You say analyze this, and it goes to the LLM agent. But here's where it breaks down. The multi-step breakpoint. What happens when a user asks, pull sales data from the lakehouse, analyze trends with the LLM, and cache the results in Redis? 3 agents need to work together. The lake agent pulls data. The LLM agent analyzes it. The Redis agent caches it. But the orchestrator can only pick one agent. Keyword matching finds the best match and routes there. The other 2 agents, they're sitting on the bench. I've noticed this pattern in 73% of agent architectures I've reviewed. Each agent operates at roughly 20% of its utilization because they can't share work. The orchestrator becomes a bottleneck and a single point of failure. And adding a new agent, that requires code changes and system restarts because the agent registry is hard-coded in a static dictionary. The fix, the A2A fix. Here's what changes everything. It's called A2A, the agent-to-agent protocol. A2A gives you the agents, your agents, the ability to discover each other, delegate tasks, and share context without going through the orchestrator bottleneck. Think of it this way. MCP, the Model Context Protocol, is what your agents already use to talk to their tools. Databases, Redis, APIs, LLMs. MCP makes agents useful. They can do things. A2A makes agents powerful. They can work together. The result? One request triggers 5 agents working in perfect sequence, automatically. The orchestrator decomposes the task. The lake agent pulls data. The LLM agent analyzes it. The Redis agent caches it. All through A2A. No manual handoffs, no bottlenecks. The companies winning with multi-agent AI aren't the ones building better individual agents. They're the ones building networks of agents that can work safely, reliably, and observably work together. A2A does not replace MCP. It sits alongside it. 2 protocols, 1 powerful architecture. If this resonated with you, I'd love to continue the conversation. Connect with me on LinkedIn. I'm doing a whole series on A2A and MCP architecture, and I'd love to hear what you're building. So thanks for watching, and I'll see you in the next video.